Okay, greetings learners. Again, today we are going to look at cosine rule. Right. Now, when do we use a cosine rule? We use a cosine rule if you have two sides and included angle. Here you'll be looking for a side. And we also use cosine rule if you have all three sides and one angle, and here you are looking for an angle. Now let me explain what does this mean, especially this included angle. Okay, now if you have a triangle, you have these two sides. The included angle will be an angle that is formed by those two sides that you know. Okay, so that is an included angle. Okay, now uthini ke cosine rule. Cosine rule says in any triangle A, B, C, then A squared is equals to B squared plus C squared minus 2AC cos A. Right. Or it can also mean that B squared is equals to A squared plus C squared minus 2 AC cos B. Okay, can I just make a correction here? It's not AC, but it is, sorry, it is BC here. And then C squared equals to A squared plus B squared minus 2AB cos C. Now, if you are doing grade 11 and you are seeing this for the first time, it might look like it's hard, but I'll just show you how to memorize this formula in a simpler way. Now, can you see the side that we started with? Here it's A. Remember, we have a triangle. Remember, we've got triangle A, B, C. Okay. Now let us name the sides here according to the angles that they are opposite to. So if this is B, this will be small b. If this is C, this will be small c. If this is A, this will be small a. Okay. Now, if you are looking for this side, this is A. Okay. The A squared. Now at the end, you must have cos of an angle opposite to this side. Okay, so if you have side A here, at the end you must have cos A. And in between here, you must have the other two sides, the sum of the other two sides, but they are all squared. Okay, and then minus, we have a 2 here, and then it's BC, same side. But now they are just multiplied to each other. They are not squared. Look at the second one. We've got B. At the end, we've got cos of B. Okay. And then we've got the other sides, A and C, the sum of them, and they are squared. Minus 2. And then same sides, but they are not squared now. They're just multiplied to each other. Look at the last one. We've got C squared. And then we've got the cos of C. Okay, and then we've got the other two sides, A squared plus B squared minus 2, and then the same side, just that they are multiplied to each other and they are not squared now. Now we want to prove the this rule. Okay. Now remember that when proving these rules, you must be able to prove them from an acute angled triangle and also from an obtuse angled triangle. Okay, and an obtuse angled triangle, we've got A there, B, and C. Now let's just start by looking at the acute angled triangle. Okay, now here we must construct a height. Remember, let's construct a height from A. So we have 90 degrees there. This is our height there. Okay, now this whole side is A. Okay, now if I name this, it's a D here. Let's put a D here where the height meets the base. We'll put a D there. That point is a D. Now if I name this DC, if I name DC to be X, okay, it means BD will be A minus X. Do you agree with me? Okay, we are just looking at BC and we are dividing BC by 2. Not that we are dividing it by 2, but we are making it to have 2 portions. They are not necessarily equal. So if I say this is X, if I say this is X, DC, if I say DC is X, that means the other side will be A. Remember, the whole side, since it's opposite to angle A, the whole side will be A. And then minus X, because I know this one is X. Okay. Now let us look in triangle ACD. Now, would you agree with me that after constructing my height, I will have 2 right angle triangles? Okay, we've got this right angle triangle and the other one, ADC, the one that I want us to look at now. Okay, now in this triangle ADC, okay, Pythagoras theorem says that B squared is equals to H squared plus X squared, and we get that from Pythagoras theorem. Okay, we get that from Pythagoras theorem. All right, now let's move further. Now look at this, cos C, cos of this angle. Remember, cos is adjacent over hypotenuse, so cos C is X over B. So X will be equals to B cos C. Okay, now you must remember this. Okay, now let us look into another triangle. Now we're looking at this triangle in the beginning, but now I want us to look at this triangle. Now in triangle ABD. Now in that triangle, let us do Pythagoras theorem for this triangle. You can see that C is a hypotenuse. Okay, so we say C squared is equals to H squared plus A minus X all squared. Okay, and this is Pythagoras theorem. We are using Pythagoras theorem because we have a right angled triangle there. Okay, all right, now let us work this out. This is C squared equals to H squared. This is the squaring of a binomial, so it will be A squared minus 2AX plus X squared. Okay, now can you write this such that all that is squared will be together and also in an alphabetical order? So C squared is equals to we start with a squared plus h squared plus x squared minus 2ax. The purpose here is to have h squared and x squared together so that we can replace it. Remember this, h squared plus x squared, h squared plus x squared, so that we can replace it by b. Okay, and remember here we've got x. Okay, so we can replace x by this because we've got what x is equals to. Now let's just substitute that. C squared is equals to a squared. Now instead of this, okay, we put b squared minus 2a. Instead of x, we put this b cos c. And we have proven cosine rule. Now you can do the same thing. This is c. Okay, you can do the same thing for b squared and also for a squared. Okay, I hope that's clear. Now let's see how this thing is done in an obtuse angled triangle. Okay, now in an obtuse angled triangle, let us also name the sides. We've got a small c there, we've got a small b here, we've got a small a there. Now let's just construct a height there. If we construct a height, we've got to extend this and then drop the height there such that they are perpendicular. So this is our height and this is d. Now let us name these sides. Okay, we've got a here. Let's say here the CD is x. Okay, it means the whole of this, it will be a plus x. We are looking at BD. It's a plus x. Okay, now let us look into triangle. In triangle ACD, and let us do Pythagoras there. Look, which triangle is ACD? This triangle ACD, that's the triangle I'm talking about. Okay, now from there, let's get Pythagoras for that triangle. It will be b squared is a hypotenuse, b squared is a hypotenuse, sorry, b is a hypotenuse. Now for the Pythagoras theorem, it will be b squared equals to x squared plus h squared. That is Pythagoras theorem. Okay, and then let us find cos of this angle. Now you would agree with me, as we have done, same thing that we've done on sine rule. If I hide this, angle C will be this one. This will be angle C. Okay, this will be angle C. Okay, okay. But on this triangle, we are not looking for this angle, but we are looking for the other side of an angle. Okay, since this is a straight line, okay, so this angle on this side should be 180 degrees minus C. So this angle is 180 degrees minus C. So here we are looking for cos of 180 degrees minus C. This angle is 180 minus C. That angle will be equals to, remember, cos is adjacent over hypotenuse, so it will be x over b. X over b. Now let's sort this out. This is second quadrant, and cos on a second quadrant is negative, so this is minus cos c equals to x over b. So x is equals to minus b cos c. Okay, These are the two things that you need to remember, this and that. Now, let us look in triangle ABD, the big triangle ABD. Now, you can see that it is also a right angled triangle. Okay, this is a hypotenuse. Now let us do Pythagoras theorem for this, for the big triangle. So it is C squared equals to H squared plus, remember the big side is A plus X all squared. That's from Pythagoras. Let's work this out. C squared is equals to H squared plus A squared plus 2AX plus X squared. Right, now let us write this with the purpose of having X squared and H squared together, A squared and H squared together, or it's already in that manner. So we can see that A squared plus H squared, we can replace it with B. Sorry, the A is fine, okay? The A is fine, so we must group these two together. Plus the X squared plus H squared plus 2AX. This one, the X plus H, the X plus H is a B squared, so we can replace it. So A squared plus B squared. Now let us do some substitution there. X, look at X there, it is minus B cos C. We've got a plus here, so the sign will end up being a minus there. 2AB cos C. And that's how it is proved using the obtuse angle triangle. Here we're using the acute angled triangle. Okay, now let us look at the application of this rule, cosine rule. Now remember what we said earlier, the cases where we are able to use cosine rule is a case where we've got two sides and an included angle and we are looking for a side. Or if we have all three sides and we are looking for an angle. Okay, now let us write down the cosine rule for this angle. Sorry, for this triangle. Now you can see here we are looking for a side, so it will be X squared. Okay, remember here we've got a small a, we've got a small c, sorry, we've got a small b, which is an x. This will be equals to a squared plus b. Sorry, we're not going to take, oh yes, we are right. So it will be a squared plus it is a b that we are not going to take because it's what we are calculating. It will be c squared minus 2ac and then cos of b. Remember, it's b there. Okay, now let's substitute. Okay, we've got x squared equals to, the a is 55, it will be squared, plus c, which is a 47 and it is squared, minus 2 multiplied by, the a is a 55, the c is a 47, and then cos of 48 degrees. Remember, I don't like rounding off. So if we are looking for x, you just have to put all this under the square root. Okay, 55 squared plus 47 squared minus 2 times 55 times 47, and then cos 48 degrees. Just do it like that, put it under the square root, equals to, and then if you go to your calculator, you will realize that you have 42,13 centimeters. Okay, now let's look at this one. Let's look at this one now. Now here you notice that it is an angle that we are looking for. Okay, now there's an easy way I want to show you. For an example, look at this. If you have c squared equals to a squared plus b squared minus 2ab cos c. Now, if you are looking for an angle here, if you manipulate here, you will realize that you will have at the end cos c equals to a squared plus b squared minus c squared all over 2ab. We do not have time to manipulate here step by step, but maybe at home you do have time. You can manipulate this, and this is what you will find. Okay, and then at the end, since you are looking for an angle, then you'll say arc cos of all this. Okay, now here, this is what we are looking for. If you look at my formula here, the one that is subtracted, can you see? These two are added. The one that is subtracted is the side opposite to an angle. Okay, so here we are looking for cos x. It will be equals to the two sides each squared, 25 squared plus 29 squared minus the side that is opposite to an angle, so it will be minus 36 squared all over 2ab. In this case, it will be 2 times 25 times 29. Okay, like I've said before, I do not like round offing, so here you will have x equals to a cos of 25 squared plus 29 squared minus 36 squared over 2 times 25 times 29. And then you can put this on your calculator and you will find 83,27 degrees. Okay, now I would like you to try this on your own. Again, the most appropriate book will be a book from grade 11 where you will find the exercises for this. Thank you.